Oh. Hi folks, if you can you hear me? Oh, there we go. Make sure I had a black screen. If you're watching this after the fact, make sure you check the description below for time codes. These tend to be really long streams, so the times codes are a great way to get around into different parts of the stream that you're interested in. Or just turn it on while you're doing something else and hang out and check out all of the deep dives that we're going to cover. So we're going to take a few minutes, let people join us, and I'll say hellos while we're doing that. So, hello Oats and Honey. Hello Chi. Hello Dexter. Hello G3 Holiday. Hello to Jack Burton, the first comment on YouTube. Hi David, and hi Bruce. Thanks to David for taking notes as always. Hi R. Darsanod. Hello Beata. Hi Love the Factory. Aren't you in Colorado usually? Love the Factory? Or are you usually in Florida? And I'm just blanking. I'm hoping everything works. I need to have a disclaimer. My computer has not been too pleased with me. Not been cooperating, so if I disappear or USB doesn't work, then yeah. Not to be completely unexpected. Hi Johnny. Hi Brian from London. Hi, yes, usually Colorado. I'm right. Hi 560. Love the work you're doing on bare metal Pi stuff. Thank you. Hi Charles. Hi Anthony. Do I sound all right? Everything good? Johnny's in Hawaii. Awesome. Yeah, yesterday was not very fun. I spent most of the day trying to debug my computer. Not good. The computer boot ups, it was USB problems, and I pushed USB a lot. So that's like ideally right now I have like 4 HD streams or 2 HD streams in a normal stream, video stream. Hello Mark. Hi X Micron. Hi Cheatstaffer. Hello Neurocom Dre. Hi Michael on LinkedIn. Welcome everybody. Hey PT. And bye, State of the Fruit. Yeah, my stream is during an internal meeting, so I always miss the meeting. And Phil and Lamore have to run it. Awesome, thank you Luke. Luke says everything sounds and looks top notch. Hi Affinator and WebBSK. What we're working on, we're going to talk about the Raspberry Pi 2W and getting CircuitPython running on it without an OS, so just bare metal. Hi Andrew R. Hi Sydney from Brazil. Hi David Buchanan. Hi Brian. I never trust laptops, always good to have a few spares. Yeah, this is my desktop unfortunately. But I ordered a second motherboard for it that will come tomorrow, and that will tell me whether it is actually the motherboard that's causing me heartache. It's like, as somebody, I've done a ton of USB, and so what I'm getting in, like if we look at the desktop, move this down, scooch that down. If you just look at my dmesg, what happens is I'm getting, oh, it's not too bad. So there's UVC problems. But I'm getting these like device 3.2 is like not able to enumerate. So it's like, but if I unplug everything except like a keyboard, I still get that, which means that it's like, means it's something that's on the board itself, ideally. Oh, nice. Bruce S got a 02, or yeah, 02W and a Raspberry Pi 400. Apple for scale, thank you. Hi, Minnesota Mentat. Got a Chromebook. Mark says, time to get an M1 Max. No, I'm like currently, I mean, the M1s look really cool, but you can get so much more for your money with a desktop, and it doesn't have to worry about, you don't have to worry about thermals anywhere near as much as you do if you have a laptop. So I'm happy having a desktop. Like, I could buy like 3 of these computers for the cost of a MacBook. MacBook Pro, which is what I used to do, and I still have one on my desk, so I still use that. But all right, let's do housekeeping. An idea: keep a Pi 400 spare synced with your main one. Big USB stick. They break. Seriously, they break. Oh, interesting. How does it break? I actually did buy a second one because I'm about to play around with it. Hello, Unexpected Maker. Yeah, I'm just complaining about how my computer has been failing me in the last couple days. Oh, awesome. Pi 4 with 4 gigs of RAM, but missed a 20W or 02W. Yeah, the work that I want to do today should mean that we should be able to bring CircuitPython to basically the whole Pi line in the end. New desktop in the pipeline. Beata points out you can't use a desktop on transit. Well, I've worked from home for the last 5 years, so once I stopped working down on the couch, it was like I really don't need a computer anywhere else. Hey, Mark. Grink, huh? Okay, let me switch back to let me do the intro / housekeeping. Whoa. I haven't like gotten my windows as big as they can be. So hello everyone. If you don't know, my name is Scott and I go by Tan Newt online. I work on CircuitPython for Adafruit. Adafruit is an open source hardware and software company based out of New York City. I work remotely for them though, so I live and work in Seattle, work in my house. Yeah, so open source hardware, open source software. CircuitPython is open source software. It brings Python to microcontrollers and soon to be Raspberry Pis as well. So microcontrollers are really inexpensive computers, and like Raspberry Pis fit that bill too. So it's an all-in-one, all-encompassing experience. So yeah. If you want to support me, you can support me indirectly by supporting Adafruit, who pays me to do these streams, by going to adafruit.com. You can chat with me and a lot of others on the Adafruit Discord server by going to the URL adafru.it/discord. That's what the middle box here is. This is a deep dive. It happens almost every week. I'm going to take the week of Thanksgiving off in a couple weeks, but for now, next week will be on Friday as well. It's normally at 2 p.m. Pacific, which is when this stream started. So that's the typical time. Occasionally I'll switch to Thursday if I want to do it, but I've been going really consistently, so I've been like okay with taking a week off as well. It typically goes for 2 hours or more, depending on if I'm stuck into something. If you have any questions, as folks know, I like to take tangents and talk about stuff. So this is a chance for you to ask me anything about CircuitPython, Python programming, microcontrollers, all that sorts of stuff. I'm happy to take questions. And yeah, I said next week is on Friday. I usually have a note about the cat, cat cam up here. That is Spook, and he's usually in there. Okay, so, oh, and one last thing. I'm going to be, Tom's Hardware, I think it's Tom's Hardware, has a PiCast stream. And they asked me on to talk about this bare metal CircuitPython on the Raspberry Pi work. So I will be on that next week. It's Tuesday at 11:30 a.m. Pacific time, which is 2:30 p.m. Eastern time. So I'm going to take a look at that, or I'm going to be on there. And it's funny because I actually like mentioned the idea last time I was on the PiCast, and they like wrote a whole article about how that was something I wanted to do eventually. So it's kind of a nice nice circle into like, oh, I'm actually working on this stuff now, and I've proven it out. So cool. Let me say hi to some folks that showed up later and get caught up on the chat. Mark Olson is laying on the couch, loving my office. Decent i7 laptop with external monitor. Next to it is a Pentium 4. Oh, ooh, duplicate of the other. Interesting. Can't wait to see what the CircuitPython team comes up with for the 02W. Mark says. Hi, Mark. Mark Tomlin, that is. Hi, Hims Labs. Hope things are going great with you. It's been a frustrating couple days. Yes, starting yesterday, I got up yesterday. Hi, Chi. Got up yesterday, tried to type my password into my computer, and it didn't work. Over and over and over, and I was like, I'm pretty sure this is right, and pull everything out. I knew that sometimes USB stuff can interfere if something's misbehaving. So I reduced it down to my keyboard, and then my network didn't work. So yeah, it's just been a huge pain. And then on top of that, yeah. Hi, Oats and Henny. So mostly what I've been doing besides fighting my computer this week has been working on SD card support. And I actually tweeted out a thing yesterday saying caps lock. I don't even know how to do caps lock. It could have been that, but I ended up getting a different keyboard, and I also used Colmac, so it wasn't clear to me whether I had accidentally reverted to QWERTY. I wonder if there's a setting to be able to see the password. I'm in my house. I don't need super secure passwords or anything. And I work on all open source code. So really not critically important that I have good computer access policies. Yeah, so I tweeted out a thing about wanting an SD card library. Oh, Beepo myself, which is an adaptation of Dvorak for French. Interesting. I really like Colmac. I'm glad I did switch. Dylan asks, did you have to get rid of your custom keyboard? I didn't end up doing it. On-screen keyboard. Oh, I could do that. Part of the problem is that I also get my passwords in muscle memory, the ones I type all the time, so I don't necessarily remember what it actually is. That's the other problem. I figured it out. I'm happy the stream seems to be working okay. Okay, so SD card work is ongoing. Let's see if the overhead's working. Oh, it looks like it is. So what I ended up doing here is I ended up getting I think I talked about this last week. I ended up getting a USB sniffer from SparkFun. And it works okay. So all these wires here, they go over to a Salier, which is a logic analyzer. And I used this week to confirm that I was actually talking to the card. The problem with this is that as you add more wire and trace lengths and stuff, the slower kind of the card needs to go in order to work correctly. And the bootloader actually wasn't starting up CircuitPython if I was trying to start from the card itself. I got a USB sniffer. Sorry, it's an SD card sniffer. USB's on my mind, obviously. Might need to get you a System 76 launch keyboard. How do you feel about medicinal switches? I have not used those switches, but I don't need another keyboard. I've got plenty. Thank you though. Like right now I use a Keyboardio, and it's like a split keyboard. Basically, I really like split keyboards. I wouldn't go back. I should also mention, for those of you who are watching on YouTube, I do have it set to normal latency again, so that we can do the text to speech or speech to text automatically. So if you do find that you're behind the stream, you might want to switch over to Twitch. It's important to me that the stream is accessible, but for those of you who are able to hear the stream and may want it to be a little quicker, you can go over to Twitch. Hopefully that's using. SD card sniffer, yeah. Everybody corrected me. 4x4 trellis for important passwords. That's an interesting idea. Yeah, signal integrity problems. Yeah, so I wasn't. So what I ended up doing, you'll see here that I now have the an Ethernet plugged into this, and so Tack had told me like, oh, like he got NetBoot going, and NetBoot's a way to have the Pi for boot from another computer that's running TFTP, and it worked pretty well a couple days ago, but I was trying it today, and it's just super unreliable, and it's very slow. Like, it's slower than me switching the SD card back and forth, which is a little bit of manual work, but it's like, at least it's reliable and it's quick, which is frustrating. So I'm kind of like sick of working on that. So I was thinking I would move to the 2W today, because I think people want to see the 2W kind of going. So I thought that would be fun to do that. And that won't use the NetBoot stuff. Daniel says, what would you recommend for recording data from a 9DOF IMU sensor? Maybe a Pi Zero or Pico or Arduino Nano or Uno Nano better for this? I think this is an interesting case for a Pi Zero with CircuitPython, actually, because the nice thing about CircuitPython bare metal on Pis is that you'll have SD card storage automatically, and you can record to that. The Pico can do it as well. I would not do either Arduinos. The Nano might be okay, but I don't remember what microcontroller it is. The Uno I would definitely not do because it's 8-bit. It depends a lot on kind of like how frequently you want to pull the data to, Daniel. It's not Pixie, it's just TFTP. So I found a Python implementation of a TFTP server from Facebook, and I've been using that. But it's like super unreliable. Like today, it's just been like, I can see that it's pulling files off of it, but it's still not booting. It's just extra frustrating on top of my USB problems. Generally, for my passwords, I use LastPass. It's just like a few that I type in manually. Anthony says, thank you for understanding there are disabled users. Glad you are accessible. Yeah. That's what, like, folks who want to be up on the stream can always go to Twitch. But I really do like the auto captions. As somebody, like, I'm perfectly abled, but I still like to watch TV shows and stuff with captions, especially if they're British. So this was helpful. So thanks to SparkFun for making and stocking this. So once I got the net booting working, I could then isolate the SD card traffic that was due to what I was doing in CircuitPython. So that was really great, and I was able to confirm that I was talking to it. And I got far enough to the point where I needed to follow all those SD card specs. I mean, yeah, I also tried using TFTPD HPA, and it had more trouble, not less trouble than the Python version. I don't get it. I don't get why. Like, the Raspberry Pi has the IP address burned into it, and they're just on the switch next to each other. It just, like, maybe I could try it and just see. We can see whether it's... Let's do that. I could see if it's working. So let's go to the desktop. Quirky likes captions too. Desktop. Come on. Stop typing ends. I really need to update my... I have this thing that detects when my hand is on my trackball and makes my right hand on my keyboard mouse triggers. But it's using a proximity sensor right now, and it's not very reliable. So if I'm not in the proximity range, I type ends instead of mouse clicking. Which is, if you've ever chatted with me and seen me type ends, that's what's happening. TFTP is supposed to be pretty dumb. It should just work. I know. I don't get why it's so slow. Why it's so unreliable. Do you have any recommendations for making string formatting a bit faster in CircuitPython code? I don't. I bet it's a lot quicker on things with floating point for some reason too. I bet it's like the RP2040, just so you're feeling that Cortex M0. I do a lot with TFTP. Okay. Make sure your server is a static IP. I didn't actually do that, so I had to update it today. Because I had network troubles on top of my USB troubles. Quirky says f-strings. So f-strings internally in CircuitPython just get translated into this format, the dot format equivalent. Similar string format performance on an M4, actually maybe 10% faster. Yeah. Here, I'll show you. Let's at least try this. I might need to get more USB cables because I, for some reason, used them for other things. So I'm plugging in. So we have the Silicon Labs, and here's the cool thing about this. Oh yeah, and don't hate me. I'm running it as root to get the port. I don't know how to change the port number. So if I just turn it off and back on. Ooh. I just heard the sound of a delivery. I did order this really cool PCIe card that has 4 USB host chips on it. So the PCIe card has 4 high-speed USB ports, and they're all independent, which it's not cheap, but I'm very excited about. So here it did work pretty well, which is cool. It did boot up nicely, so that's awesome. Oh, that might have been the card that just got delivered. I actually kind of want to push my luck and see if I can't get the Salier sniffing, because this should be fixed. Anyway, I shouldn't get distracted with this. I should do the 02 stuff. Seeing CircuitPython written in Rust at some point would be fun. Getting it running on a Raspberry Pi would also be fun. Calling it RPi would be a full circle at many levels. I'm pretty sure there is a Rust Python already. I think I found it. Like, yeah, there's Rust Python. Like, people have already written a version of Python that's written in Rust, which is neat. I don't know how it compares with size or anything. Hello, Christine. Ah, Chi says there's a show password button hidden. But if you install a different theme, you can get a show password button at the login screen. That would be amazing. 4 USB chips, yeah. It's not cheap, but it's I got a smaller version of it recommended by Paul from Teensy. I'm just in my Amazon here checking it out. Highpoint Technologies. So they have USB. USB HBAs. So this is what I got. I got one of these. And they talk about this shared architecture where there's 4 ports, but there's only 2 controllers. And it's a PCIe 3 times 4. I splurged and got the PCIe 3 times 8. And it's 4 separate USBs. Not this one, not the USB 3.2, but this one. It's like $250. But I do so much with USB, and it's so nice to have isolated USBs. It's 8 lanes of PCIe 3. It's ridiculous, but I'm excited about it. It just got dropped off, but obviously I can't stream while I upgrade my computer. Oh, I heard it again. I'll have to check that out. Okay, so let's, I'm glad this worked, but I kind of want to switch gears because I want to show off the 02 stuff. So I have a 02 here, and sorry for the lighting. I know that. So this is a 02W. It's awesome. I haven't actually used it yet, but it's going to be awesome for CircuitPython. It's 15 bucks. Oh, it's HDMI mini, which I forgot to grab a cable for, but that's okay. So let's just go to the overhead and we'll get this set up. I would like to, the main challenge with this is that it's an older chip, and the older chip has an older interrupt controller. So most of the work that we've got to do to get it working is to get the interrupt controller working. And then hopefully USB will work. Okay, so I'm gonna disassemble some of this. I will get back to this next week. One thing I should note, you remember I had this I/O carrier board that had the broken micro SD card? I actually swapped to use the broken one because I'm using this like weird, not quite an SD card thing on it. So I was like, oh, perfect. Like I can't break it more, and if I do, it's fine because it's already broken. So I did that. So I'm just disconnecting the Salier. The reason that the zeros are so great for CircuitPython on this is because they're designed to have micro B connections, which means that it will be much more obvious that you can just plug it in and treat it like a drive. And sorry, I don't have, this is the HDMI thing I was using last week that is in the shop at Adafruit that I got from there. I don't have it set up today, so we won't actually be seeing output, but I didn't want to push my USB luck that much. Okay, so I'm going to pop this off because it should just work on the 02. I was thinking maybe I should label that. So here's the 02. It's a lot smaller, and I'll have to remember that the SD card is here. So what we're going to do is we're going to try to build the bare metal CircuitPython for it. And unfortunately, I realized I don't have a power switch, so I'm actually going to have to pull it, like unplug and plug in the power, which is going to be annoying. But I have this debug header that I made, or a debug hat, if you will. Should be pretty handy here. And also my limit for the debugger as well. CM4 with 10 USB ports. But how many host controllers is that? I think people get, I would love to know how many host controllers something has and what ports are on what host controller. It's not the plugs that matter, because the problem that I have is a misbehaving USB device can like basically DOS the rest of the devices on the host controller. So yeah, I'm all about, oh, and I'm upside down. I'm all about getting as many separate host controllers as I can. Because then the USB devices, it's three hubs, because hubs are different than host controllers as well. I'm all about, like, I want my USB devices completely isolated, which is why I'm excited for this card. Okay, so I don't know why the SD card stuff's not working, but I don't want to debug that right now. So I do have a reader here, a micro SD card reader, so I'm just popping it between that and that. And I also I had a power supply already, so this micro B cable is just a power supply for it. So actually, why don't we just check the bootloader? And power is the outer one. So let's just see if we get anything here on our terminal output. Hopefully it doesn't go poof. That would be bad. It shouldn't do anything. Nope, doesn't look like it. And I don't have the HDMI set up, so I can't see. Hi, G3 Holiday. Didn't manage to get one. That's all right. I do want to support the original 0 as well. It's just like, that has a different CPU architecture. So I wanted to start with Pi 4 and like work my way back, but it's only really like 4 different chips, right? Like there's not, and the peripherals are almost identical across all of them, especially the first 3. So it's really like, knock on wood, sorry, not going to be that hard, hopefully, to go from one chip to the other once we have it going. Are you a student under Adafruit? I am not a student. Thank you for asking, though. I work for Adafruit. I'm 35, so I'm not a student. Although, I guess people could be students at 35, but no, I am not. I work for Adafruit. If I want to play along at home, would a first-gen Pi 0 work all right for tinkering with the dev branch builds, assuming pushing changes to a branch? I am pushing to the branch, but you'll have to do some work that I will talk about today to get it going, because you'll have to change the compiler. So I'm starting with 64-bit builds, and then like you'll need to switch the compiler for 32 bits. And then there's maybe like a little bit of assembly that you'll have to switch out to. And yeah, this is a custom PCB I did. It's available on OshPark. I still haven't tested I2C, but if you do want to pick it up, I've shared the link before, and I'm happy to share it again. It's meant to be like hand buildable. I'm like relatively experienced with soldering stuff, but I'm happy to give instruction if people need it. So yeah, this is a custom PCB to be able to do this. Like this is a serial converter, USB to serial converter, and it's like the pin out here is designed to just plug into those because I think it's pretty standard. And then this is SWD, which is really, an SWD connector, but it's JTAG over it. And then I haven't actually tested the JTAG yet. So yeah, so what I wanted to talk about today is like I was really focused on proving out the concepts with the Pi 4, but now that I've made a lot of progress on that and that this has come out, I really wanted to like tweak all my build processes so that we could actually support more things. Michael says, I love how fast the Pi 02 is. I'm planning on making a Pi portable project once I have time. Awesome. Yeah, I think the main challenge with supporting Pi boards is actually having the USB broken out so that you can like plug it in and have it show up as a drive. So the original 0 is actually more interesting than say like a Pi 2 or a Pi 3, because I think both of those, like they don't break out the USB device directly. They use it for like the host. Like so many Pis are designed so that you plug a keyboard in. They're not designed to be devices themselves. Okay, so what we're going to want to do is let's take a look at some code. Ardosson found the project. Thank you. So there's a couple things that I have to do. Let's do desktop with over. No, overhead's not interesting. Oh, I don't even have my text editor open. So the normal way in CircuitPython that you would build a new board is you would say make, and then you can say board equals such and such. And so this is relatively new from last time, but I wanted to do like, actually, what did I call it? So these are all based on the folders in the directory, right? So if I do the make again, and I do 0 to W make, and I'll clean it first. Let's see if it compiles. That's where we start. One thing we're going to have to account for is that the memory addresses of things have changed. So we're going to need to think about this. This I don't think will boot, but we could see. Actually, I don't think it will. If the 0 is supported, would the Raspberry Pi Model B be supported since they use the same sock? Yeah, probably, right? Again, the challenge is the USB being broken out. We'd support it, but you wouldn't have a good way of editing the files on it. But yeah, since it's the same sock, like it's really not too hard to support. It's more about how the USB is connected on the board itself. So like the original Raspberry Pi is probably interesting from the like VGA video output, if people want that. Ooh, I just splashed water on my desk. G3 Holiday, if you need KiCad source files for that, I'm not sure I linked to them, but I'm happy to share them as well. So if anybody wants KiCad files for these, for the hat, let me know. I'm happy to do that afterwards. Okay, so we did successfully build, but I have a feeling that it's not going to work. And the main thing the reason it's not going to work is I think the address for all of the peripherals is different. I believe it's 7E or something. So we could just see what happens. We should be able to JTAG it still. So yeah, let's just see where we're at here. So we're in the wrong build directory, and I should delete that one. That's the old name. But we can go under this Raspberry Pi 02W. We have a kernel image, and we could just copy that over. Copy here, overwrite, sync, yeah. And let's just pop it in and see if we get anything. We'll probably crash. Oh, and it's not spring-loaded. Okay. So I'm amazed you haven't created a script to automate the file and sync. I know. It's partly because it also does the mount automatically. If it was just a copy, I would have done it already, but oh, we have a light. Nothing else. Oh, you know what? I don't know if this OpenOCD thing might not actually work because that's configured for a Pi 4. I don't like OpenOCD, but we can figure it out. Because of these configs. I don't like OpenOCD because I have to manage config files like this. But I bet there's a Pi 3 version. It would be nice to get this going. All right, time to Google OpenOCD Pi 02W. I'm actually on the mailing list for this. That's for the V1. I've seen you doing that over and over on stream, and I can't imagine how many times you've done it off stream. I know it's true, but after yesterday or this morning where I was having trouble just with the network boot, and even when the network boot was working, it was slower. So it was unreliable and slower for me, so it was just like, I can do it, it's fine. It's probably better if we just find the Pi 3. It might come with it. What browser is that? This is Firefox with the tabs. Tab tree or something. Okay, here's a... see if that works. So the Pi 3 is Cortex A53s. Ugh. Should have thought about this. Ah, here we go. SD card setup. Custom Linux kernel for debugging. Don't need to do that. Enable JTAG debugging. I do that. Here's the pinout. And I'm lazy. I don't like doing this. So I made my own thing. And I guess I'll download this. Download. I don't need to open it. We can just save it. I really like it. I like the tree tab style thing. Downloads. I don't know why I can't autocomplete. What? Is that what it is? Ah, there's a dash. I was so close. Address already in use. It's not, this isn't. I'm trying to remember why that was. Yeah, look at all these USB errors. It's been quiet so far, which is good. Maybe the config has me. Huh. Why does the Raspberry Pi 4 one start on a different port? Kill the previous OpenOCD attempt. Oh, there's a telnet port command. lsof. I don't have it. Oh, yeah. It's OBS. Okay. What was it? Bat. Telnet port. Telnet port. I don't even use the telnet port. Ah. What am I doing? OpenOCD. Boom. Listening. Awesome. This one. Repos, CircuitPython, ports, Broadcom. This is one of those things where it's like kind of annoying to have to do, but also really nice to have set up once you are doing it. So this one. Okay. And then I'm going to source repos tinyusb gdbinit. There we go. So it looks like it got, oh, the tick timer is not working. Okay, so this makes total sense. So there's a system timer that counts up from startup. It's great. The problem is that on the Pi 3, all of the addresses changed. So what we need to do is, maybe we'll hack this for now. But I think we talked about the SVD files. So SVD is for system view description. And there is a specific thing for, Cortex-M usually, but I'm bringing that to the Cortex-A world. So I have this here. So I was gonna do it as a 2837 02W. So basically we need to generate a separate header that has all of the different addresses for the peripherals that we're gonna access. Maybe we could do a deep dive into applying SVD files to new processors. Yeah, so that's, I mean, kind of what I'm doing right now. I've built this Jinja system on top of that, and we can go into that. So Jinja is a Python templating library, and so what it does is it takes like these things and does like code-like things, or if it's two curly braces, then it's like a substitution of a value. So what I've got is I've got it kind of split out where I have these peripheral imports that I'm doing. So what it ends up being is one giant XML file, but I'm using Jinja to like glom together the pieces. Like, so there's a peripheral kind of subtree of the XML. And so what I do that is I'm using Jinja to like put those peripheral pieces together so that I can do exactly what I'm going to do today, which is like generate one SVD file for the 2837, one for the 36, one for the 2711, and like all of the 4 chips that are on all these Raspberry Pis. Because like they have a lot in common, like all the register layouts for the peripherals are the same. It's just like you can see here that there's like a peripheral base value that's being passed in when it's being generated, and that is like one thing that is changing, that changes with the different devices. So we're just going to update this to, and then let's find our generator file. Ports, common, close all this. So in peripherals here, so this is the Broadcom peripherals library, and there's this gen SVD. So this is doing all the pin muxing, and the pin muxing is, I think, pretty much the same, except for the earlier chips, earlier than the Pi 4, earlier than the 2711, have a lot fewer things. So what I want to do here is I'm going to duplicate this. And we're going to generate a 2837. That's right? And the base address is going to change. The local base is probably going to change. We'll just pass the same alt functions in right now because they're basically the same. And the interrupts are basically the same too. So we should be able to get a lot further if we just update. I think the peripheral base address is 7E. Where we can find that out is one place is, so I think they'll, maybe I'll just Google it. 2837 base address. Oh, that second one was actually, so this is a good reference, and this looks like a really good reference too. Oh, it's 3F, but it's mapped to 7E. So we will have to update our memory map as well. Well, we can see what works for us. Is there a write-up describing the process and steps support to a new platform? Ooh, what ARM chip is it? I think doing a different Cortex-A would be really cool. But there's a lot of work that I don't know. So I think let's try 3F. Ooh, it's an FPGA. Expand all button on that page. Yeah, right. The ARM logo is probably also 3F. So that should change. That should change what we generate and actually generate something. So let's try it. Python gen. So here's the full command that I'm running. It's generating the SVD files and then taking them and converting them to headers, which I guess I should update here as well. And that worked, it looked like. So what we get in the end is under SVD gen, you end up with these two files, and they're giant, like 42,000 lines of XML. And then you can see here that like the VC mailbox peripheral, the hard processor core is ARM, dual core Cortex A9. Is it too small, Chi? You want me to make the font bigger? Does it have any other hard peripherals? The XML file is big. Yes, it is. It's giant. And then what the second stage does is it generates a bunch of headers. So they go in Broadcom gen, and then you get another giant file that has all of these like structs for all the bits, all of these pound defines for all the bit positions and masks, and type stuff too. So it allows you somewhere in here. Where is it? Yeah, here it is. So it has all of the bases of all the peripherals, and there's no UARTs 2 through 5 on this chip, so that's a problem. But then what it does provide you is you can say like GPIO, and it gets substituted for this thing that takes the address and casts it to the type. So it makes it really clean, I think, to like reference in C code. Hi, Dave. So that should be enough to get us further. We could actually test this. So in GDB, I have the SVD extension loaded. So I can do SVD load peripherals. Where am I? I don't know what directory I'm in. I'm in Broadcom. SVD or source. Maybe this will autocomplete peripherals. Yeah. Broadcom SVD Gen 2837, and I can switch this to SVD load. And I always do that. Okay, so now I can do SVD, and we can verify. Some of these peripherals have identifying registers, and I have those encoded here. So if I do SVD UART1, oh, hi Robot Meister. OpenOCD, Pi 3, reconnect. So we can actually read the memory. And that like kind of looks okay. I'd like to drive HMI or DisplayPort from the FPGA fabric. This part I'm pretty good at, and run CircuitPython from the HPS. I'm happy to chat more offline with you about this. A9s, Cortex A9s are 32-bit Cortex A's. I mean, if you can get them going, the other thing to think about is USB. So getting USB going is really handy too. I'd love to support FPGA stuff with CircuitPython. It's just tricky. Let's try a different one. I think, well, so the GIC doesn't exist. We've got stuff on here that doesn't exist. And I didn't fill out the registers for the interrupt controller. That's unfortunate. At least we're able to read these registers. Vendor ID. Which ones of these do have it? SysTimer. Compare channel. That doesn't necessarily seem right. FPGA and CircuitPython. Yeah, I kind of settled that I really wanted a Stemma FPGA using a Mach X02. That was kind of what my plan was for that. So this doesn't look like it's right. It doesn't look like these are the right address. So I wonder if we could just find another reference. So what is the maybe it's 7E BCM. These docs are not very good. I just re-download all these things. Oh, here's the memory address. GPU peripherals are at 3E. Local peripherals are at 4. ARM timer, IRQs, and mailboxes are at 4,000. Hi, Paul. Oh, that reminds me. Paul says that they're an hour late because of changing from summer to winter time. The U.S. changes time this weekend. So next week it will be a different time if you're outside the U.S. So a heads up with that. What's the equivalent SVG for CPU info? SVD? Core-related interrupts, interrupt controller. registers. Ooh, this is the interrupt controller registers. Nice. Okay. I'm going to have to clone that. I'm going to have to look at that. Core mailboxes interrupt. Can this be the year we just collectively decide to get rid of daylight savings time? Thanks for the reminder, Paul. I appreciate that. That's annoying. We're going to need this. We're going to have to update the interrupt controller if we want USB to work. 64-bit timer. Let's see let's open 2835. Let's open 2836. Is that the same thing? Yeah. This is why I think it's going to be relatively easy to support, because they always just say, like, it's basically the same thing. We just updated the CPUs. I think morning people like daylight savings because I'm a night owl, so I'm the opposite. I think that is funny though how that works. Address map. Let's look at the address map here and see what it says. So these are video core CPU buses, ARM physical addresses, and we're talking about physical addresses. This puts them at 2000. Oh, RPi 3 base address. This shouldn't be so hard. This is why yeah, good docs. Good docs are well worth it. Raspberry Pi 3 tutorial. Delays. Uses ARM system registers, uses the system timer, and the system timer is at what address? MMIO base plus 3000. And MMIO base is .3f. So this should be correct. I know that there's like valid. It's for the GIC, which we don't have. I just go around. Yeah, I did. Oh, I added all these valid registers on the one thing that I can't check. Okay, so let's just see if it works now. Although we're gonna need to do something so that we import the right thing. we need to make sure we import the right header file. So let's do a Bacon Press. Just got my 02W today. Love the packaging. Glad you like it. Let's make a new file called chip. I don't know. Is that a good name? And we don't actually want it there. I want it move. I want it outside gen because I'm not going to generate it. And then I'm going to say pragma once. And if Broadcom version equals 2837, gonna include Broadcom Gen BCM 2837 LPA.h else if BCM version equals 2711, oh, how did I get in there? Okay, so now we can say, maybe it should just be defines. What's a good name for this? I don't know. Defines, I don't know. So now we have to find, we need to provide BCM version. So in our make file, we're going to do, I think I have a, yeah, BCM version equals 2711. Am I not using Sublime Text 4? $41.21, I assume that means it's Sublime Text 4. I like Sublime Text. I've never used all the fancy features for other stuff. Okay, so that looks good. And then we have to find any includes that we did. So BCM 2711, LPA-H. Oh, monitor just disappeared. So in all these places, we've got to update this to include the defines instead. So I'm just going to supervisor port, peripherals, defines. Maybe it should be like platform. I don't know. And then an SD card. This doesn't actually work yet. And then in peripherals, there's a UART one. Let's do the UART. If we could get UART output, we'd be well on our way. so it looks like the rest of them are in peripherals itself. So maybe it should be called like hardware. Broadcom. Interrupt handlers defines. This is going to have to change too. I've tried VS Code because I know a lot of people like it, and I just couldn't do it. It was always popping a window up, and that really, really bothers me. Oh, am I using this? Well, here you go. There's the base address there. I don't think I'm using this file anymore. This has got to change. But I don't. Maybe I'll just do it temporarily. Set peripherals to register access. Do that. One thing at a time. We'll have to look and see if the system timer thing happens after the RAM is initialized. And the glare is making it hard to look. So we've got to generate the headers again. I like that all the generated files are in gen folders. Yep. Okay. So if we do make again. I just stubbed these out. Where did I put them? I agree, the pop-ups are easily the worst part of VS Code. Icebreaker, Bitsy, FPGA, and the teensy form factors in pre-launch. The FPGA folks are doing a lot of good work making it simpler to do, but it's still pretty complicated. It's empty. Okay. So now we've got a new build, so let's just give it a shot. So unplug, pull the card out. Yep. Maybe it just feels faster because I'm actively engaged instead of just waiting for it. The license is nasty. All right, let's see how far we get. I mean, this looks weird to me that we weren't able to, like, that the counter is 0. That seems not right. And we're not getting any UART outputs. We're not getting that far. Let's OpenOCD it again. And it's possible that our view into the world is different here than it is from ARM. Yeah, so we're still... It's still 0. We're in main 183. Now, does this happen when the MMU is on or off? That is one question. It might be main port init, wait for safe mode reset. Okay, so it is happening later. Yep, the counter should be incrementing. SVD. Like all the compare channels are identical. They were identical last time as well. I'm actually a little surprised it's not memory faulting. 3F. 3F is in that first range though, isn't it? So if we think about our memory map, it's cached. Where's the GPU memory in that case? Right? 3F is before this. So what does it say about GPU memory? Like this is the video core. And the video core has less than. This is not right. Can GDB do a direct read from the counter without using SVD, or maybe have SVD print the address it's trying to read? Yeah, you can do it directly. It's just like way simpler. Like you could do px uint32 t star of the address, so 3f 003,000, right? Did I guess that right? And that prints the address. But then if we dereference it, it's 0. Unexpected Maker has an unrelated question that says, in CircuitPython and MicroPython, when you use a define const function object keyword args with 1 to 7 keyword args, how do I determine which were actually set? I want to update members of a struct, but only the ones that were passed in. I have it working, but it stomps with all the default const if that keyword arg was not passed. Yeah, you'll basically need to have a sentinel value that your keyword args are set to by default. Basically, internally, you say, if it's the default, then don't change it. Like, that is the right address, right? It's possible it's going through the MMU. It's 3F. Oh, it's 3004 for the low one. Still 0. Get the current counter frequency. That's ARM CPU. How does one ask the MMU what physical address it is reading? So there's an ARM instruction that you can provide an address for, and it gives you back the. There's an ARM instruction that will give you a physical address from a virtual one. One thing we can do, so 3F is within this first gig of range. So what we could try doing is just saying, well, for one, we don't need this second table. I don't want to delete all this. But for testing's sake, let's just basically, mark it all as not cacheable. In fact, we could just have we could just turn it off. But let's just see what that does. Oh, come on. It is very weird. It could be like a debug bus thing. Like, it depends, like, it's possible the memory view is different for the debug stuff. It's possible there's unexpected caching. Because even if you say it's volatile in the compiler, the CPU may cache still. Like, there's no signal from the compiler's notion of what's volatile to what the CPU is. Like, it's a separate system. And this is what I just built, right? Just now, yep. I gotta get me a switch if I don't have a switch already. USB 2 power switch. I don't really like this camera connector. It hangs off the end just a smidge, and it makes me worry that I'm gonna knock it off. Can you access the LED? Debug print to the LED. That's a good point. Oh, look, we got some output. Maybe the clocks are different? Yeah, that's UART output. It's possible that that was just a fluke. Oh, something's happening. The J-link shows up as orange. And I'm unable to connect to it. Well, we changed something. And we got the garbage output again. It makes me think that could be CircuitPython output, but maybe our we're not getting really need to change how this works. So it's the wrong speed. That's why it's garbled. So if we just go to UART and do we compute it? Here is what? 500, but maybe the Pi 3 has different UART speed. How does it do that? Oh, interesting. It does a mailbox call to set a clock to 4 megahertz. I wonder what the default is. Yep, Charles, you're spot on. Logic analyzer or scope might tell what baud rate it is. Yeah, that's true. Hi, Mr. Who 30, and hello, Johnny. Did I don't know if I said hi to Johnny. Sorry. Prismax Man says, are you programming the Wi-Fi in C? Yes, I'm using C to program the Raspberry Pi. Yep. It's CircuitPython is written in C. What do we think? What do we think the baud rate is? What's your guess? We could actually query it. That's probably wiser. Or we could actually set the root. We could copy what it's doing. What are the odds that it is 4? Maybe there's other docs that say what it is. See, so they're like setting the clock rate for the UART clock. I don't know what it defaults to. Raspberry Pi OS. This is also for the Pi 3, I think. But there's not just a... maybe it is just 4. Core frequency. Is the baud rate based on the core clock? It is, Bacon. It is based on the core clock. You can see right here, it says, since the UART1, SPI, and I2C derive their clocks from the core clock, the serial clocks can also dynamically change. Which is why there's a second UART. Oh, we can just set it to 250. Yeah, maybe let's do that. So here, let's do 250 megahertz. And we'll build that. Ah, it's right there. Pop it out. Since we're not running Linux, it's probably best to not run it where it's going to get too hot. One thing I haven't added support for yet is actually reading the temperature. That would be cool. I'm kind of surprised that it's getting into a state where we can't get into it. Oh, maybe that's the problem. Core freak equals 250. Of course, it's not clear to me how much the it's not even clear to me how much the bootloader actually does, and what it's just like a patch that gets passed into Linux. That's the problem with a closed source bootloader, is that you can't see what it's doing. You just have to guess. You either have to guess or you have to rely on good docs. And this stuff does not have good docs. The RP2040 docs are amazing, but the regular Raspberry Pi docs are lacking, at least for the hardware itself. Did we already get a blip? No! We got non-gibberish. Okay, so it's stuck in the SD card stuff, which is good. But it's not surprising that that doesn't work. So let's just skip it. And by skip it, I mean we go into boards, board.net, and comment it out. Hit save. If you had the HDMI cable connected up, would there have been messages there? The bootloader would have had messages, but not necessarily CircuitPython. Yeah, maybe. Yeah, maybe. Because CircuitPython, if it seems like the output was actually working, we could try it. I think I have a cable. I just have to dig around. Yeah, the NDAs with Broadcom are the reason, I think. Happy to see that their other chip, the RP2040, is better documented. Okay, let's just make sure that we can get all the way to the REPL here. And then we could test pins too. That's not where I want. Random comment on GitHub suggests that the default UART 0 clock rate is 48 megahertz. I think this is UART 1 that we're dealing with. UART 1 is the weird one. I really should figure out how to do this all. But it's fine. Okay. So we should be able to get all the way to the REPL. Although, no, it's the same USB, so the USB should be okay. That will be our next step. So we got the frame buffer messages, but we did not get further. So we're stuck somewhere else. So, but the OpenOCD looks like it's working. So let's take a look where we're at. Hard fault handler. Okay, so we need to source peripherals, Cortex, GDB, and let's try it again. Haha, look at that. Oh yeah, how much memory do we have? This should be fine. Allocate memory. That length is suspiciously long, although that's like 32 megabytes. Yeah, the ARM stubs have been helpful too. I have looked at those. Allocate memory. Allocate remaining memory. Data abort from same level. Is that because we're not marking it as normal memory? Maybe. It could also be... Like that should be okay. Oh, they had trouble with Broadcom. They do hire people away, so I could see that. Check how the memory is set up in the MMU. Agreed. It's a data abort. We could tweak, now that we know that that MMU bit is a problem, we can change it. We can fix it. We can do a better fix. And I think a reasonable fix is just to like I'm wondering if we should, maybe we should just hard code it for now. Let's just hard code it. If EC, what did I call it? Version? Is that what I called it? It's in defines. Yep. So we'll do this if it's BCM version. let's just do this. Ah. And we don't need this second table at all. Because it's not up there. We can make it smaller later. I don't usually have this much trouble with this. Hi, Patrick. All right. So we're going to want to set peripherals to register access, but they're not in a separate table. And I got a rogue N in there too. Yeah, we got further on the 0-2, which is awesome. I didn't even know what to expect, how far we get. So this is the thing that sets it. So let's do kind of like it in order. The amount of memory is smaller than the Pi 4. Yep, that's true, Charles. So it's we have a gig. It's 2 megabytes a piece. This is where my hex just doesn't scale this much. So the first 2 megabytes, how much is 2 megabytes? What is that in hex? 342x. K is like, let's see, 2 megabytes is 2 times 1024 times 1024. So it's 200,000. 2 0 and 4 zeros. So oh, you can't see my whole screen. And then you set it as device. So what is 3F? 3F 00. By that. Wait, am I wrong? 504. So peripherals are 504 to 512. And there's no thing there. 3F. I know that it's smaller, but Raspberry Pi SD card work will make SD wire look more interesting as an Adafruit product. What is that? SD card reader and a mux. Huh. I was thinking something like this would be cool and to be able to like have a micro that's acting like an SD card and will tell you when you've done it wrong. When the process is wrong. So we know it's 512 megabytes, which means that it's 256 minus 8. If it's a total gig, we start in the middle. So that's the GPU. I don't know if you can hear the teenagers going by or not. They're having a good time. Okay, there we go. So I think this is right. So this is the code segment. This is all RAM, which is actually the same, which is fine. We have the last 16 megabytes of 512 megabytes RAM are shared with the GPU, and then we have peripheral register access from 3F to 4O. So let's give that a shot. Let's make sure it works. Empty device read only. Ha ha ha. Oops. At least in C, the compiler will tell you to add a semicolon. All right, so let's do the SD card dance. It keeps me active. Is that a good excuse? Okay. Heyo, look at that. We have REPL over, oh, had crashed. Tried to hit enter and now it's unhappy. Well, we're making progress here. Let's do the dance again. Oh. Doesn't look like we crashed. But it like stopped outputting. Huh. It's definitely running still. I don't know how to get, I see this output from time to time, but I don't know how to actually request it. Like, Beata says, yay. So I don't know why it stopped working. Because it looks like it's still running. I wish I could get this output for the core I actually care about. It's just showing cores 1, 2, and 3, and I'm running on 0. Like, I don't know how to trigger this. It just happens from time to time. I wish I could do it all the time. So we're in main C 470. We don't have a file system that CircuitPython is reading yet, right? Correct. Haven't gotten that working. I was just running it from boot init or board init to try and test it. Let's see what line 470 is. Man, it would be nice if it worked. It seems like, oh, it could be all the interrupt stuff. It could be that. All the interrupt stuff is wrong. Let's see. Dave wants to know what Unexpected Maker said. It took me over a year to stop putting semicolons in my Python code. Now I keep forgetting to put semicolons in my C code. And Dave was asking what Sion's first, who is Unexpected Maker, what his first programming language was. Yeah, my guess is this is all interrupt problems. Maybe? That's likely my guess, because it's going to do all the GIC stuff, which is probably not. Well, certainly not right, because there is no GIC. As far as I know, maybe there is, and they just don't use it. So yeah, I think we've got 4 minutes. Are there any other questions folks have? I have a couple things. So my next steps are to do the register layout for the legacy interrupt controller. And that is done. That will be done in this svd peripherals directory. I have this legacy interrupt thing. You can see I haven't added any of the fields yet, so I need to do that. The captions are ahead of the audio in my stream. Oops. Is there a non-interrupt driven UART driver? So the UART is not interrupt driven, so I'm not exactly sure why that's a problem, but the USB machinery should be going. So if there's anything triggering an interrupt, it's not going to be handled correctly. And it should show me if I'm in an interrupt, and it's not, but it's like, I know it's something that I've got to get working. So I think this is as good as we're going to get on the stream today. So one thing I'm going to do is I'm going to get all this set up, and then I'll write an equivalent of in peripherals we have, not in SVD, but in Broadcom we have interrupts, and we have this handle IRQ, which is referencing this GIC CPU thing. And so basically we need a different implementation of this function for the 2837. So that'll be my next step. And then hopefully it'll be working, but I'm going to go grab that package and maybe actually open up my computer and set that up. I don't know. Either way, I'm going to push this code. So if you do want to follow along, you can check it out on my GitHub. which is github.com/tannewt/CircuitPython. You can check it out there. If you click branches, you can see the most recently updated ones. There's a RPi one, one that has all the changes for this stuff in it. So that's the place to follow along. I think we've made reasonably good progress getting all the MMU stuff set up. It is nice that A53 is like ARM v8 and stuff. The older we go, it's 3 and 4, Pi 3 and 4s are can be ARM v8. Previous ones before that are ARM v7, and then the original Pi is like previous to like that naming. Fallow says, "Great progress today. Thank you." It is progress, and it's important to recognize that. Oh, and thank you for the link to the repo. So I'll make sure and get everything that I've done checked in, just because given all my computer trouble, I want to make sure that all the code that I'm working on is pushed publicly or as a backup. So I will do that. Unexpected Maker's first programming language was BASIC on the Commodore 64 and the Micro B Model B, and then assembler on the Commodore 64. Dave says it was BASIC on the ZX80. The ZX80 as a home computer stuff didn't really take off in Australia. It was definitely some around, but mostly Commodore, and then Apple dominated. But all of our schools had Micro Bs. You all are the perfect audience for me trying to make Raspberry Pis into something in homage of Commodore 64 and ZX80s then. So that could be cool. Patrick says, "Thanks, Scott. Now I can go back watch from the beginning, and I didn't watch last week yet, but that thumbnail is awesome." Chi had a Spectrum when they were a kid. Yeah, it's cool. I think we definitely want to do that. So one of the major things is doing USB hosts, but once we have SD cards working, we should be able to get it done. Fellow had Visual Basic. Oh, several people are typing. I think we're hearing people's first languages here. Programming languages. Andrew R. had BASIC and assembler on the Acorn Atom. Charles's was BASIC and assembler on the Altair 8800. Cool. I hope you all agree with my desire to make CircuitPython into something equivalent. Dylan learned with some C++ Arduino precursor that ran on Lego Mindstorms. Our Dorsenad was on an Apple II and had an Atari 1040 STE next. Chi says, "I'd love to type a game in from a magazine and press run, and it does not work." Linux 203, BASIC on the C64 here too. Mr. Who 30 says, "How about Amiga and Atari during those times?" Patrick says, "The Magnavox Odyssey 2 for PC, no ability to save, type in a program and don't turn it off." Unexpected Maker went from C64 to Amiga. My dad went Apple ICE 2C, maybe 1CE to XT clone. Paul did assembly on pre-Apple II and ITT 2020. Beata, Apple Basic, then QBasic on the PC, then Borland, Pascal, and C. Bruce S. says, "My first real language was Pascal, so I was mostly a mainframe person in punch cards." Linux 203 says, "My daughter started with Python 3.9. I started with PHP. Greg says, "Does logo count?" Sure. That's one thing that Phil Lohr actually kind of excited, because we have a turtle library. So doing turtle in CircuitPython would be awesome on a TV. So I think there's definitely like a jive for that. Unexpected Maker says Apple IIe. Shiny Squirrel Club says TRS 80 Model 3, Timex Z80, Sinclair 1000, and Atari 130XE. Is this why you all are watching the stream? Because you just want to harken back to those days with this CircuitPython bare metal stuff? It's definitely true. Like, I think there's something to be said for the simplicity of it. At least I hope so. It's a new branch. We want to understand pointers still. Yeah, that's interesting. So Python doesn't have pointers. That's what I was wondering. You are all hardcore. I mean, so I should say I'm maybe a little younger. I probably the first programming language I did was PHP, because I went from the web world. So I learned HTML, and then I wanted to make it dynamic, and JavaScript really wasn't super a thing. So I did PHP as a way to like change the HTML I was generating. Mr. Who says, I still have my logo bugs from a long time ago. I'd love to update that. We could update those for CircuitPython. R. Darsanad says, I definitely started with that at school on a Thomson M05 or T07. Shiny Squirrel Club, 42 years, 30 plus languages. I don't remember all of them. I don't, yeah, all of them. Thanks, Google. I know I use Google a lot too. All right, let me do housekeeping and we'll wrap up. So thank you everybody again for, let me switch, for hanging out. It's been a pleasure. Glad we could make some progress, but you know, there's always more work to do. Always more work to do. So it's never just a walk in the park. Yeah, so this interrupt stuff, I might continue on that a little bit more. We'll see. Yeah, so this has been a deep dive. Deep dive with Scott happens normally Fridays at 2 p.m. Pacific, which is right about now. Reminder, and thanks to Paul for reminding me of this, the US changes times this weekend, so next week will be at a different time if you're outside the US, so heads up for that. If you want to support me, you can do that by supporting Adafruit by going to adafruit.com, purchasing some hardware there. We've had some Raspberry Pi stuff, but it's been selling really quickly. So sign up with emails if you want to get notified. That's how I snagged my 2W, is I got an email, got out of the shower, and like immediately went to my desk to order it. If you want to chat with me and a lot of other people, ask more questions, collaborate, the Discord servers where that happens, it's a chat program. You can go to the URL adafru.it/discord. That will get you into our server in Discord. And I think that's it. Thank you again to David for taking timecodes, and thank you to Patrick for collecting all those timecodes in the repository. That's a great way to kind of search around in all of the previous episodes of Deep Dives, which are quite a few now. So there's a lot there. They're all like 2 hours long. So thank you again to Patrick and David for that. And and lastly, PyCast on Tuesday. I'll be on there and we'll be talking about all of this work. So if you've been watching these deep dives, you'll probably be up to date on my thinking about that. But it should be cool anyway. And with that, I will switch to the cat cam and pet the cat. After I unhook myself. Have a great weekend. You too, Paul. I'm excited to get to see my fam. Okay. Cats. Hi, Spook. You have a good life, don't you, kitty? Yeah. Have a great weekend, everyone.